In this video, we're going to look at the key features of quadratics and applications of quadratics. For this first problem, they give you the equation y equals negative 0.5x squared minus 4x plus 24, and they're asking you to complete the table. In order to do that, we need to know how to use the calculator. So what I do is I read that equation out just as I did, and I actually, in my head, I'm thinking it in terms of words, so negative 0.5x squared minus 4x plus 24. From then, I can use translation into the calculator. The negative button is this button down here, so I'm going to type in that negative button and then press the 0.5 on the calculator. So 0.5. Once I've got that, then I encounter the x squared. In order to get an x squared in there, you have to protect it with parentheses. So every time you see an x, put parentheses around it for your calculator. So we're going to start with an open parentheses, enter the value for our x. So that could be the negative 12, negative 4, 0, or 4. So if you start with the negative 12, we should be getting a 0 for our y value. So when we carry on, we're going to close that parentheses up. Now for the x squared button, to get that exponent of 2, we need to press the actual x squared button. That'll get the exponent of 2. And then we can hit the minus for x again. So we got to open the parentheses up and type in our x value. So in this case, negative 12, being careful to press that negative button, and then plus 24. So each of those are individual little buttons. Once you hit enter on this, you should be getting a 0 for your x value. So I'd recommend pausing this video, trying this out multiple times to make sure that you are getting all of the values in the table. So that's 24, and then 0. Once you've got the values of x, of y, then you can go about graphing it. So I start here at negative 12, 0. That's on the x-axis. So I start with a negative 12 on the x-axis. That means that's my first x-intercept. And that's true because when y is 0, that's going to tell you an x-intercept. So x-intercepts are when y is 0. Then we can carry on. We've got negative 4, 32. So that's at this point up here, around. Negative 4, 32. It looks like that could be a vertex, but we're not entirely sure yet. So let's keep going. 0, 24 is right there. So that's our y-intercept. So just like how x-intercepts are when your y value is 0, the y-intercept is when x is 0. And then lastly, we've got that last little x-intercept at positive 4. So when we draw a rough sketch of this graph going through those points, it looks like we are facing down. And we can tell that it's going to be facing down because of that negative in the very front of our quadratic next to the x squared term. If that's a negative, it means you're facing down. So that does mean that that top point is the vertex, because I will always provide you with the x-intercepts, y-intercept, and vertex in the graph. You just have to make sure that it is in fact either the highest or the lowest point. So negative 12 and 4 are my x-intercepts. The vertex is at negative 4, 32. And the y-intercept is at 24. This one is a new one, the axis of symmetry. The formula for that is x equals h, and your h value is the x value of your vertex. So this is just x is equal to negative 4. You're just taking that h value and setting x equal to that. And that just means that it's this line going down here, an imaginary line that divides your quadratic into two equal parts. Every point reflects over that line. So now that we've done the key features of quadratics, let's look at the applications of quadratics. So for applications, you always start with a graph of a quadratic equation. And I like to start at the origin because it makes life a little bit easier. So when I'm starting at the origin, we're told that the ball is kicked and reaches a height of 8. So that means that the very highest point is at 8. So this is your height. And then it lands 12 inches away. So this is how far it lands. So it's going 8 to 12. Given just this information, I can write the equation of this graph because I know that halfway through is going to be the vertex. So taking that 12 and dividing it by 2, I get 6. So that means that my x value is 6 and the height of the graph is at 8. So this is the vertex, and that's really helpful because then that tells me the h and k values. And that allows me to write the y equals a times x minus h squared plus k. So to solve for a, I can start by substituting the h and k values in by getting x minus 6 squared plus 8. And then for the x and y, I can use an origin point because this is where it crosses. It's going to cross through 0, 0. That's our starting point. So both x and y are 0, so I've got 0 equal to a times 0 minus 6 squared plus 8. The mistake that students make with this problem is that they tend to enter everything after the a into their calculator. But that's inaccurate because order of operations tells us we need to multiply only by what's multiplying. So just this part here goes into the calculator, not that 8. So one trick that we use is we subtract the 8 from both sides automatically so that we have a negative 8 on the left-hand side. And then when we enter this into our calculators, we get 36a. Negative 6 times negative 6 is positive 36. Then I can divide both sides by 36. And it's not absolutely necessary, but it is a good skill to build. You want to simplify that fraction down. Both of these values can be divided by 4. That's the greatest common factor that they have. And we get negative 2 over 9 for our a value. And we need this because then our equation becomes negative 2 over 9 times x minus 6 squared plus 8. So that's a huge step to take. The last little bit is just checking the word problem itself, because then it says that at 10 inches, when it's 10 inches away, the goalpost is 5 inches high, and we want to see if that is possible to make the little triangle go over. So when you're playing table tennis or finger football, this little triangle is being kicked up and over. Somebody's holding their hand. So in this case, the hands are being held at the goalpost, which is 5 inches high. And we want to see if that paper will make it over. So in order to see that, we've got an x is 10. So let's substitute that in. We've got negative 2 over 9, 10 minus 6 squared plus 8. So when I type this into the calculator, we've got that negative 2. And then to get the over part, we do divided by. So that's to tell your calculator, do a fraction. The 9, and then we do the parentheses, 10, I'm going to shorthand this a little bit, minus, not negative, the 6, and let's close that parentheses up, raise it to the power of 2, so x squared, the x squared button, and then add the 8. So when you type all of this in, you'll get y is equal to 4.4. That means that the paper is going to be right around here at 4.4 inches, which is below the goalpost. The goalpost is 5 inches high. Your paper only made it at 4 inches high. So therefore, the ball, I'm going to say quotes around that, will not make the goal.